Now, we're just going to work some additional molality problems. You should have worked a few of these when you watched the video. Now, one thing we need to start with that you should know is molality is a lowercase m, and the molality is equal to the moles of solute. Remember I said yesterday when we talked about molarity that top number was the same, but the difference was the bottom number. And what was the bottom number? Kilograms of solvent. So it is only the kilograms of the substance that is doing the dissolving. So as I look at this first question here, it says, determine the molality of the following solution: 10 grams of sodium hydroxide in 300 grams of water. First of all, what is my solute? What is my solvent? What is the solute in this particular problem? Okay, Tyler? Sodium hydroxide is the substance that is being dissolved, and it is being dissolved in the solvent, which is water. Okay, water. So, first thing I need to do is I need to convert my 10 grams of sodium hydroxide into moles. Once again, that's a flux capacitor move. So I have 10 grams of NaOH. To convert that to moles, I know that 39.99711 grams of NaOH is 1 mole of NaOH. So my grams cancel. My label's going to be mole NaOH. And remember, I'm not rounding this value to significant digits because I'm not finished with my problem. So I take 10 and I divide that by 39.99711, and I get a value of 0.250018. I think that's carrying it out enough. So, as I do my molality, I know that my lowercase m is equal to my moles of solute. I just calculated that value. So that's 0.250018 mole of NaOH. What is my kilogram of my solvent? Well, here's water, but it is in grams, correct? What do I need to do to get that into kilograms? 3 to the left. Jump my decimal 3 to the left. So it's going to be 0.300 kilograms of water as my solvent. So when I come up with my molality, I'm going to take the moles, the 0.250018, and I'm going to divide that by 0.300, and I get a value of 0.83339 When I go back to my significant digits and look, I see 3. I see 3 sig figs for each one of these. So I'm going to cut this to 3 sig figs, which would be right there. My label will be little m for molality. So the molality of 10 grams of sodium hydroxide in 300 grams of water will be 0.833 molal. If you're writing it on your own, if you're doing it with WebAssign, okay, it'll probably have little m already. Or sometimes they just do moles per kilogram like that, okay? So I don't know how on WebAssign you would get that little line over it, okay? Now, my second example, go ahead and copy it down and then we will work it. A solution made from ethanol, which is C2H5OH, and water is 1.75 molal. How many grams of ethanol are contained per 250 grams of water? What I need to do is I need to rework my equation and find moles of solute, and I do so because I know that my moles of solute is equal to the molality times the kilograms of the solvent. Once I have the moles of solute, I can flux capacitor that into grams of solute using the molar mass of ethanol. So, my number of moles are going to be equal to 1.75 molal multiplied by kilograms of solvent. When I convert that grams to kilograms, it's going to be 0.250. So 1.75 multiplied by 0.250 will give me 0.4375 moles of ethanol. Now I take that value, the moles of ethanol, so I take 0.4375 mole of C2, I think I said H5OH, right? When I do my conversion, I need to have the molar mass of ethanol, and I have that calculated already. It's 46.06844 grams of ethanol is 1 mole of ethanol. My moles of ethanol will cancel there, and it'll leave me with the label of grams of ethanol. When I do the math and I multiply the 0.4375 by 46.06844, I get a value of 20.155. I go back and look at how many significant figures I need, and I need 3 significant digits, so I would round that to 20 0.2 grams of ethanol. Any questions for me here? Here I've got one final example problem working it just a little bit differently. So go ahead and write that down and then we'll work it. How many kilograms of water must be added to 75.5 grams of calcium nitrate to form a 0.5 molal solution? So in this particular example, we are asking to determine the kilograms of the solvent. So this is a new equation, so I'm going to rework my original equation. So my kilograms of solvent will be equal to moles of solute divided by the molality. So the first thing I need to do is I need to determine the amount of moles of 75.5 grams of calcium nitrate. So 75.5 grams of CaNO3 2. I do my flux capacitor that to put that into moles. Well, I know that 164.0878 grams of calcium nitrate is the molar mass of 1 mole of calcium nitrate. So when I cancel out my grams there, I'm going to have a label of moles of calcium nitrate. As I do my math, 75.5 divided by 164.0878 gives me a value of 0.4612 moles. Now, what I'm going to do is I'm just going to simply bring that back up here. So I'll put my moles of solute right in there on the equation. So that is 0.46012 moles. My molality is 0.500 little m. So when I solve for my kilograms of solvent, I'm going to take the moles and I'm going to divide that by 0.5, and I'm going to get, with 3 significant digits, I'm going to get a value of 0.920. And what's my label going to be? Kilograms, specifically kilograms of what? Kilograms of water. So 0.920 kilograms of water.